All right, we're going to look at number 38 from the 2016 January Algebra 2 exam, number 38. So if you look here, we have solve the equation cos of 2x equals cos of x algebraically for all values of x in the interval of 0 is less than or equal to x, and x is less than or equal to 360, not less than or equal to, less than 360 degrees. That's going to be key at the end, and I'll tell you why. But that's the interval. We're in degrees and not radians. So once you get to the end, you want an answer in degrees and not radians. All right, so looking at cos of 2x, we have this reference sheet that's going to help us out. And if you look down here, we have these formulas or equations right here telling us that the sine of twice an angle is equal to this. And we have a couple others. The one that's going to be helpful for us is going to be this one right here. So I'm going to erase this and circle the one that'll be helpful so it'll stand out. This one right here, that is going to be helpful. We're going to plug that in place of the cosine of 2a. So we're going to replace that and write now 2 cosine squared a. We'll use x since they use x in the problem. Minus 1, so now we've replaced it, equals cosine of x. All right, now we're going to treat this as a quadratic. So we're going to have, we're going to subtract cosine on both sides, cosine of x, so 2 cosine squared of x, minus 1 minus the cosine of x is equal to 0. Now I'm going to rearrange it, and I'm going to go from my highest exponent down to my lowest. So we're going to have 2 cosine squared x minus cosine of x minus 1 is equal to 0. Now, if you had, let's just say we could replace cosine with just the cosine of x just for the variable x. And let's make it look like how it would look, how you normally would see it. Or not normally would see it, but how you're used to seeing something. So we have 2x squared minus x minus 1 is equal to 0. Now how would we factor that? Because that's what we're going to be doing, factoring. So this would, if we use our slide and divide, good practice on slide and divide, this would be x squared minus x minus 2. Now we factor that, you get x minus 2 and x plus 1. Don't forget the divide part of slide and divide. You have to come back and divide by what you multiply by, which is the 2. And you end up with x minus 1. Remember, you have to reduce. So the 2 over 2 reduces to 1. And 1 over 2 does not reduce. You have to slide that up. 2x plus 1. So that's going to be what we have. But now we have to convert that, or not convert it necessarily, but just change it to how it looks with the cosine. So we're going to have, coming back here, so we're going to have 2 cosine squared x minus 1, excuse me, don't want the square, 2 cosine x minus 1, and cosine of x minus 1. Okay, made a mistake here. We have, this should be a positive here, so hopefully you saw me just write that positive. And this should be a positive, so be careful. Don't make the same mistake I did. All right, so this is what we have. This is all good right here, and it all is equal to 0. All is equal to 0. All right, now we're going to do the same thing we would do in an equation when we just have x's. We're going to set them both equal to 0. We're going to have 2 cos of x plus 1 is equal to 0. And cosine of x minus 1 is equal to 0. Now we're going to get cosine of x all by itself. So we're going to subtract 1 here. And we're going to end up with 2 cosine of x is equal to negative 1. Then divide by 2, and we'll get rid of this. And then we have cosine of x is equal to -1/2. All right, and let's do the other one before we finish. We add one here, so the cosine of x is equal to 1. All right, let's look at what x would have to be, all the possible values. We only want from 0, remember, 0 to 360, not including 360. So think to yourself, and if you're in my class looking at this, we have been talking about the unit circle a lot. So think to yourself, the cosine of what value or what angle gives you 1/2? Well, I'm going to pull out my unit circle just to make sure. You should have your unit circle available. That's why we do it. Now, you might know it in your head. And if I probably thought about it, I probably know it in my head. But I might as well make sure with a unit circle, if I have it. Don't see it right now. All right. Let me get this. Give me a second. I'm going to grab it. I'll be right back. Okay, I have my unit circle. And I'm looking at it, and as I look around the unit circle, I'm looking for what angle measure in degrees will give me a cosine value of -1/2. Remember, that is the x value on your unit circle. So if I look, when I get to 120 degrees, my x value is -1/2. So x is equal to -100, I'm sorry, not -120. X is equal to 120 degrees. But if you keep going down to the third quadrant, you see that it is also the cosine of 240 degrees is also equal to -1/2. So there are two values there. All right, so those are the two values. And we're only going from 0 to 360, not including 360. So keep that in mind. Now we're looking at this other side. So the cosine of what gives me 1? Well, as I look at my unit circle, the only value that gives you 1 for cosine is going to be 0 degrees. You don't want to put 360, so x is equal to 0 degrees. You don't want to put 360 because if you look back up at the interval that they gave us, it's not including 360. That's why I put this arrow here. But it is including 0. That's what this means. So 0 is included in the interval, 360 is not. So 360 would not be a potential answer, but 0 would. So 0 degrees, so we have 3 different answers. 0 degrees, and these two over here, and that would be good for full credit. I believe this is worth 6 points, maybe 4 points. I'm not sure. I think the next one is actually worth, yeah, actually, so last one is 6 points. This one would be 4 points. All right, so I'm going to go with the other one in a little bit. Looking at number 39, we have a lot of given information. So let's just look at the given information and make sure it's all written on the diagram. Sometimes they give you a lot of given information and it's not even on the diagram. So let's make sure. So we have DC is equal to 10. Well, they have that 10 for us. AG is equal to 15. We have that. BE is equal to 6. They have that. FE is equal to 10. We have that. AB, so A, B, G, 40, they have that. G, so G, B, D, they have that, and that's a right angle, so that's a right triangle in the middle there. C is less than 90, so we know that that is an acute angle. BE is congruent to DE. Okay, now, or BE is congruent to ED. All right. Now, that's a piece of information they told us, but they didn't mark on the diagram, so we can do something from that. And GF is congruent to FB. All right, so let's look at those last two pieces of information. Because I want to, before I even start, I want to mark up everything and also keep in mind what we're looking for. So let's go and look at that. We're looking for angle A, and we're looking for side BC. This one right there. Those are the two things we're looking for. So that's a good thing to know at the beginning. All right, but let's go back to that information right here. All right, so if we know that BE is congruent to ED, then that means this must be 6. So we know that because they already give us BE as 6. So ED has to be the same, so that's 6. All right, now they said GF is congruent to FB. So that is this side and this side. The problem is we don't know FB. But if you look more closely, you realize we have a right triangle. And we have a nice little formula we can use. We know 2 of the sides. And if you're good with your right triangles, you know one of your special ones or ones you see most often is 6, 8, and 10. So that means this side is 8, which means this side has to be 8. So that's some information that we got. Let's look at some other information that we might know. Let's see. Well, let's see here. We know that this line, this entire line has to make 180 degrees. And if we know 2 of the angles, it's made up by 3 angles. So if I know this angle is 40, this is 90, well, this angle has to add up to 180 when you add all 3 up. So 40 plus 90 is 130. That means this angle CBD, that one right there, has to be 50 degrees. So we actually could mark that, and we know that that is 50 degrees. So I'm going to mark that. All right, so that's 8. And then this is 50 degrees. All right, so we have that being 50 degrees. And now we have to find 2 different angles. So think about what you could do, and we'll go over it in just a second. All right, I'm going to, first thing I'm going to do is try and find, I'm going to do the second part first. I'm going to try and find BC first. So I'm going to outline this triangle here. And notice that this is not a right triangle, so you want to be careful about what you're using. It would be nice if it was a right triangle, because we could just do a squared plus b squared equals c squared to find side BC, but we can't because it's not a right triangle. We can't use any of our basic trig because of the fact that it's not right. But, so what I'm going to do is just draw it kind of over here, separated from everything, and make it a little easier to look at. So we have this side is 12, this is 10, this is 50 degrees, and that's all we know, and we're looking for x. So I'm going to go about this using the law of sines. And so the law of sines is on your reference sheet, so I'm going to bring that up here. It's on your reference sheet. It's actually right here, law of sines. We'll talk about it in class pretty soon, if you're in my class right now. But in this, the little a, little b, and little c stands for side, stands for sides. The big A, B, and C obviously stand for angles. And the angle and the side opposite it. So for instance, let's go back and let's look here. So let's go back. A lot of stuff I'm trying to do here, so I want to make sure. Okay. So we have, let's write down that formula here. Sine A, or I'm sorry, A over sine A equals B over sine B. So A over sine of A equals B over sine of B. All right, so can we use this with this triangle? Well, in order to use it, we would have to know the angle opposite the x. So when I say that, we would need to know this angle here. All right, we don't know either one. We would need to know that in order to use it right now to find x. But we can use it to find this angle. Once we know this blue angle, we'll know the green angle and be able to use it. So let's go ahead and do that. So what we're going to do, we're going to set it up and we're going to say 12 over the sine of A. So our angle, this is going to be A now. The sine of A is equal to B. So our B will be the other side, we know. 10 over the sine of 50. All right, so we have that. Now we can cross multiply. So we end up with 12 sine of 50 is equal to 10 times the sine of A. Right, 10 times the sine of A. And got to do some work in the calculator. So 12 sine of 50. Matter of fact, I'll just do, you're going to have to divide both sides by 10. So in order not to round, I'm just going to have that. So 12 sine of 50 divided by 10 is equal to the sine of A. All right, so we'll put that in a calculator. Make sure you're in degree mode, because this is in degrees, so don't be in radians, or else the answer will not come out right. All right, so when I do that on the left, I end up with 0.9193 is equal to sine of A. Remember, if you want to find an angle, you have to do the inverse. So if I want to find A, I have to do sine -1 of 0.9193 is equal to A. So once you do that, you end up with A is equal to 66.8 degrees. So now I know that angle measure. So I can put that in, and that would be, that's 66.8. Now the third angle measure, I know would be 180 minus these two combined. So 180 minus 50 plus 66.8. So we know this over here is now 63.2. So 63.2. All right. So now I got a lot of stuff. So let me get rid of this here. All right, let me erase some of this here. All right. So now our triangle. Now we know everything about the triangle except for that one side. So I'm going to draw this triangle again, because now we know so much more about it. So it's basically like this, somewhat. This is 10, this is 12, this is x. Now we know that this is 66.8, this is 50, and this is 63.2. Now we can do our law of sines to find x. So we're going to do sine of, I'm going to do x or A. It doesn't matter if you use A or B. Just make sure and use it with the opposite angle. So we're going to have, I'll just say, I'll call this A. How about that? So A over sine 63.2 is equal to, you can use either side now, it doesn't matter. Just make sure if you use 12, use the opposite angle. So it's going to be 12 over sine 66.8. All right, so now we have, let's see, now we can cross multiply, and we get A sine 66.8 is equal to 12 times the sine of 63.2, and we want to get A by itself, so just divide by the sine of 66.8 on both sides. When you get A is equal to, do some work in the calculator. I'll be right back. once you do your calculator work, put that on the calculator, make sure and put parentheses or put it as a fraction, just to be careful, just to be sure. So it's going to be 11.7, approximately 11.7 once you round it to the nearest 10. So that's actually BC. And we'll have to now go back and find angle A. So I'm going to erase all this and find angle A. All right, what I tried to do here is I tried to draw this triangle. Remember, this is what we need. I tried to draw it over here, so that's why you see this triangle in black on the right. So we need this angle. So this is a good situation. We have a side opposite the angle. We don't know the angle, but we do know the side opposite. And then we have this side and the angle opposite. So we can do law of sines very easily. So the sine A over the sine of A. Incidentally, if you want sine of A over A equals the sine of B, sine of B over B, it's going to be the same thing. I know on the reference sheet it's A over sine of A, but if you switch both of them, it'll be okay. I'll keep it the way the reference sheet has it, just for being consistent. So A over sine of A is equal to B over the sine of B. All right, so in this case, we're going to have, we'll call the angle, we'll say that's A. So this is A, and that means that this is going to equal our little a, since they're opposite from one another. Okay, so make sure and understand that. All right, so we have A, which is 16, is equal to the sine of A, which we don't know, equals B, remember that's our side, that's this one, that's B, 15 over sine of 40 degrees. Keep that degree set. So now when we cross multiply, you end up with 15 sine A is equal to 16 sine of 40. And if you divide both sides, remember you want to get this A by itself. So we want to divide by 15, divide by 15. We end up with the sine of A is equal to 16 sine 40 divided by 15. I'm going to do some work in my calculator and be back. All right, I did it in my calculator, and I ended up getting 0.6856. Now be careful, again, we use radians so much that on a problem like this, you might forget to change it to degrees, and your answer might look all funny. So be careful. Remember, we're dealing with degrees, not radians. Right, so we have sine of A is equal to that. Remember, if we want to find A, we have to do the inverse. So the sine, -1 of 6.6856 is equal to A. So now I'm going to put that in my calculator. And once I do that, the second, remember, you do second sine, and that is equal to 43.28, or 3 degrees is equal to A. So that is your A, that's our angle. And after all that, we are done with that problem. All right? Any questions on that, ask me. I know it's a lot, so feel free to ask me any questions.